Cesium atoms are the largest of the naturally occurring elements. They have a diameter of 53 nanometers. Calculate the number of cesium atoms that would have to be aligned to a row of cesium atoms 2.54 centimeters long. So I think it's easiest to kind of think about this as these prefixes do not match. However, we do know that a nano, or we could look up, is 10 to the negative 9th. And we do know that a centi, which is like a century, is 10 to the negative second. So we could just change these prefixes back into their original values. So we have something, so for every one cesium atom, there is 53 times 10 to the negative 9th meters. We also know that we want this thing to not be 53 times 10 to the negative 9th meters. We want it to be 2.54 times 10 to the negative second meters. So we've got to multiply, I think it's easier to change this here to 0.0254. So that would mean that we have 25.4 times 10 to the negative third. Let's just change it to that. 25.4 times 10 to the negative third. And I'll explain in a second why we're doing that. So 53 to 25 is divided by 2. But then we've got to gain some zeros. So we're starting off with 1 over 1 billion. And then what would we have to divide that by to get 1 over 1,000? Well, we'd have to divide it by 1 over a million. Because then that million, you'd have to multiply by a million over a million. And that would get us here. So we're dividing by 2 times 10 to the negative 6th, because we want to get to this number. Remember, we're ignoring that one. So we're going to divide by 2 times 10 to the negative 6th. So 1 divided by 2 is 0.5 times 10 to the negative 6th, which would be 5 times 10 to the negative 5th. Oh, sorry, positive 6th. Which would, if we take this out, it would be 500,000. So we'd have to take it. In other words, there's 6 of these, so that's 500,000. And if we took it back here, that would change it to positive 5th, because we'd be going out that place, and we'd have to come back to that place. So 5 times 10 to the negative 5th.